And what I'm interested in, these are Z tables that give us cumulative areas up to a particular critical value, okay? And that's what I'm doing here. I know that the area to the right is 0.025, so I know that the cumulative area to the left of it must be 0.9750. So I'm looking for 0.9750 on my tables, so I'm just going to go to my tables, and actually this value, 0.9750, can be found on the row 1.90, and it also can be found under the column 0.06. So 0.06, it's under that particular column here. I'll just maybe try to show you that here because it's actually quite hard to see. So I have 0.9750, which is this particular value here. You can see that. Okay, it's very hard to see there. That's very hard to see, but probably a little bit better there. It's on the row 0.990, and it's actually under the column 0.0006. So actually the Z score, the Z value is 1.96. It's 1.96. It's the sum of these two values here. That's the appropriate Z score. So what we're saying is, just put it into context again. So what we're really saying is this, is that our distribution, our Z distribution is symmetrical. It's centered on 0. Our critical values, okay, that have the prescribed amount of area in the left and also in the right tail of 0.025 and 0.025. Well, the critical value over here is 1.96, okay, and the critical value through symmetry over here is minus 1.96. So what we're really saying is this, is that if our test statistic is greater than 1.96, or if our test statistic is less than 1.96, that's evidence to suggest that there's a difference, okay, in what we've observed compared to what we would expect, and in which case we would reject the null hypothesis. Now in our case here, you can actually see that our test statistic is in here. It's in the right hand tail. It is our Z for the skewness is equal to 2.7926. So we now can make our decision. So our decision, if I just move that over here, step 5 is our decision. And in this case here, we have clearly our test statistic, which is our Z of Sk, is bigger than our critical values. What we mean by that is that 2.7926 is bigger than 1.96, and as such, we reject H0 in favor of HA. And now we can infer that our distribution, that our sample distribution, or that our distribution, or more importantly, I suppose, that we can infer, yes, we can infer that the distribution that the sample has been drawn from, that our distribution is in fact, okay, non-symmetrical, okay, is in fact non-symmetrical, okay. It's not symmetrical, okay. Now, I have a word of caution here for you, yeah, okay. Just because this particular test has shown, okay, that we're rejecting the null hypothesis, okay, if we did fail to reject the null hypothesis, all that means is that there's no evidence to suggest that it's not skewed, okay. Now, skewness and not non-skewness, for example, a normal distribution is non-skewed, okay? But there's many particular distributions that are symmetrical, okay? It doesn't have to be normal. A normal distribution is symmetrical, there you go, okay? But we also have a distribution maybe that looks something like this, okay? That a distribution that is bimodal, okay, is also symmetrical. This is symmetrical, okay? Symmetrical. And this is also symmetrical. Okay? So just because we fail to reject the null hypothesis doesn't mean that what we have is a normal distribution. It just means our distribution hasn't got any skew. It's symmetrical. But it could be this, it could be this. You can actually see, I can actually argue it could be an infinite. There's an infinite number of shapes of distributions that are symmetrical. Okay? So let's just keep that in mind. But I suppose in this particular instance here, and with this particular test, what we've actually shown is that the sample seems to have been drawn from a population that doesn't have zero skew. Okay, the sample seems to be drawn from a population whose skewness is not equal to 0, and we'd be 95% confident in making that particular inference, if that makes sense. But we might be wrong, but we'll only be wrong 5% of the time. Okay guys, once again this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and I hope that this video was in some way intuitive, and more importantly I hope that was helpful for you, and thank you for watching. Okay, bye bye.